Hi there. We're going to talk a little bit about translation and rotation. And we can make some analogies between translation and rotation. We're rotating very often in chemistry. We have nuclear spin, we have electron spin, we have electrons going around molecules, we have molecules turning around in space. Spin is integral to chemistry, and we need to have these concepts straight. So I'm just going to introduce some of the terminology we're going to use. I think you're quite familiar with a lot of these things when they're used in the context of translation. So we can very quickly review. First of all, we could have the mass. Mass is resistance to force. You remember from Newton's law that force is equal to mass times acceleration. You introduce an acceleration, it's resisted by the mass, and it translates into a force. All right. You can have a velocity. That's the change in the position with time. You can combine the mass and the velocity in order to get momentum. Mass times velocity is equal to the momentum p. Now, we can take the momentum and use this to have a kinetic energy, right? So the kinetic energy is the square of the momentum divided by twice the mass, or it's mass times velocity squared divided by 2, translational kinetic energy. And finally, we have the equation of motion. This is coming from Newton. So force is equal to the change in momentum with time. Equation of motion, yeah? We have analogous values in the world of rotation. We have those here. So, in analogy to the mass, we now have the moment of inertia. Instead of being a resistance to force, we have a resistance to torque. Torque. This is the rotational analog of force. Yeah. Instead of having velocity, we have angular velocity. And this is the rate at which the angle is changing. Yeah. Now, instead of having momentum, we have angular momentum. The angular momentum is the product of the moment of inertia and the angular velocity, just as the momentum was the product of the mass and the velocity. Now, we also have rotational kinetic energy. And we take the square of the angular momentum divided by the moment of inertia doubled, and that is the rotational kinetic energy. Or we could take the angular momentum times the square of the angular velocity divided by 2 in analogy to this form on the translation side, and that gives us also the rotational kinetic energy. Finally, we have the equation of motion, and this is linking the change in the angular momentum with time. That defines the torque, the change in the angular momentum with time. Yeah. Now, I will go back to the video view and say thank you for listening to this analogy between translational motion and rotational motion. Yes. Goodbye for now.